Alright, let's look at the Theorem 5, solutions of non-homogeneous linear equations. Alright, so we have this nth order non-homogeneous linear equations. Alright, remember that the non-homogeneous means that the right-hand side is not equal to 0. Alright, let's say we have a particular solution, which is the solution of the non-homogeneous equation. Right. Then the complementary solution, this is actually the one with the solution for the homogeneous equation. So we turn the right hand side equal to 0, then find the solution. Right. Then here's the conclusion of the theorem. It says that every solution can be written as a combination, the sum of particular solution and the complementary solution. All right, so let's look at a very small example. All right, so here's the initial value problem. Y double prime plus 4y is equal to 2x. Right, and the initial conditions are f of 0 equals 5, and not f of y of 0 equals 5, and y prime of 0 is equal to 7. All right, let's say that the particular solution is given, which is 3x, and complementary solution, you can find it through characteristic equation. So it's a c1 cosine of 2x and a c2 sine of 2x. So therefore, every solution y can be written as the sum of these two. So 3x plus c1 cosine of 2x plus c2 sine of 2x. Right? And the great thing about this is having this complementary solution is that it gives us flexibility, because a particular solution, there's nothing we can do, we can't really change it. But the complementary solution, we get to change the constant c1 and c2 so that we can choose those values correctly, accordingly, so that we can satisfy the given initial conditions. All right, so let's use the first initial condition. So we're gonna use the first initial condition here, and plug in x equals 0. All right, so that's 0 here. Cosine of 0 is 1. You get c1, and the sine of 0 is 0, so you just get c1. So using the first initial condition, c1 happens to be equal to 5. All right. And if you want to find the c2, we'll probably have to take the derivative. So I take the derivative of y, right? So I'm going to get 3 from here. And derivative of c1 is just a constant. I'll just put that here. Derivative of cosine of 2x is negative 2 sine of 2x. And derivative of c2 sine of 2x would be plus 2c2 cosine of 2x. All right, then we can just plug in x equals 0 here. You get 3. Right, sine of 0 is 0. Cosine of 0 is 1, so it's a plus 2c1. And this is going to be equal to 7, right? Then I'm going to subtract the 3 from both sides. We get the 2c1 is equal to 4. And then I'm going to just divide through by 2. You get the c1 is equal to 2. All right? Then we have a solution for the initial value problem. So the y is equal to, right, particular solution is 3x. And we found the c1 to be 5, so it's going to be plus 5 cosine of 2x. And we found the c2 to be, actually, I messed it up somewhere. Oh, sorry. I labeled this as C1, and it's actually C2, sorry. So this is C2 there, and that's C2 and the C2. And the C2 is 2, so it's going to be 2 sine of 2x. Right? So this is the solution of the initial value problem given here. All right, that's it. I hope that this was clear.